Where do you think DFMA fits in a design process? It's a very interesting question. But before that, can you tell me what are all the sub process in a design? Let's say that you are interested in a new product development. NPD stands for new product development. So the question is, what are all the different processes that are involved? If you were to do a new product development, where will you start? Very rare. There is no unique boxes or answers for this. Where will you start?
Identifying the need.
Need.
What you need.
Need assessment. Then,
The relevant product.
sorry, relevant product.
The same product is need. Potential market existing product.
So need assessment, then existing product. What is the process that lets you do this and then find the gap?
Functional conceptual.
Yeah, in FCD you might have studied it, but what is the tool that is used to understand this? If you go to,
House of quality.
Huh?
House of quality.
House of quality. You remember the house of quality? You had different boxes like this. This will go like this, and something will come from here.
They have triangle and
Yeah, and finally you have ranks that will go through this. Remember? It's a very bad way to show triangle and all that. But you remember house of quality? So basically what it does is, it goes and asks people what you want, and then it tries to compare existing products here. And then it's a nice method to quantify the difference, and finally it will give you ranks here that will identify the gaps for you. So this is simple. Okay, so this is level 1. So you know what is to be done, or what will be the feature of the product that you develop. Then
potential market.
okay, potential market. Let's say there is market. Okay, you went to KPMG, and then KPMG said that there is market for this, so you are ready to invest in. These days these are done by your funders, you don't need to worry about it. Who is going to invest in your company will do that for you. Okay, now after that, let's limit this to the product design life cycle kind of stuff. From here you try to come up with a concept design. Okay, then what do you do?
KYC. Know your customer. Who are the customer, like middle class or
Yeah, but that is taken care here.
potential market?
Yeah, because need assessment, you need to know your customer to begin with. Yeah, then
Model of the product.
what model?
Model.
Okay, so that's not there in the concept level. So you do a CAD model and do what with it? Optimization in the CAD model itself?
And concept validation. You need to check concept is validity.
Okay, validation. Validation from what perspective?
From engineering perspective. Assembly, manufacturing.
Well, yeah, okay, engineering perspective. In engineering, what will you do? When you say engineering perspective, can you give me like 2-3 sub?
Manufacturing.
Same thing, because we are discussing about that, whether it is manufacturable or not. Okay, then if let's I mean, don't forget, but let's imagine that you are not sitting through this course and I'm asking this question. You really didn't think about manufacturable and assembly and all that, right? So at the CAD model, what would you do?
Prototype.
From the CAD model directly prototype. You would have done this for your PD lab if you have done your PD lab products. What did you do? you would have done a cost analysis, fine. That is also similar to your
Material.
see, there's one step that you, because you come up with that, that's what the concept meant, right? This, when you say concept, there's not going to be a single concept. You might come up with multiple concepts and you might want to evaluate them, and that's what this cost analysis. Using a cost analysis, you choose something that could be one, or you can do a efficiency analysis, or it need not be just a cost, it could be something else also. Okay, so based on that you come up with a concept. So we set concept, but the concept selection itself is a process. After that you build a CAD model, you try to validate it. What I was trying to tell is more from a performance perspective. You try to simulate. What do you try to simulate? You want to look at the performance part of it. Okay, you don't worry about the tolerance, you don't see whether it is workable right now. You imagine that whatever I give it in drawing, they should be able to do it. Okay. Then what do you do?
Prototype.
You can go to prototype. Okay, then that's it. Go to the market. Then what do you do?
Actually, into the users like about all team.
Then the prototype needs to be validated. There are some errors they need to go back.
Okay, so you need to go back where?
To the model.
Design.
To the CAD model. Is that all?
To the concept.
To the concept you need to go back. Okay.
And realize where the problems are occurring and transform. It's kind of a cyclic process.
This is kind of a cyclic process. Okay. So, but when will you stop the prototyping?
When the prototype doesn't have any problems. When the prototype doesn't have any problems.
The prototype does not have any problems with respect to what?
Performance. Tolerance.
With respect to performance here, because that's what your validation on computer has been, or anything what you are talking about. It should, these two should compare well. Okay. Then what do you do? But usually it is not. Computer gives you some value and prototype will give you some value. If you have built any product, you would know this. Okay. Then what? Fine. So let's say it's all correct so far. You just did a cycle. It's a cyclic process. Then you finally you choose a prototype. Then what do you do?
Then we look at the manufacturing process.
Okay. So then you go to manufacturing.
We look at the manufacturing.
Actually, this itself is manufacturing only. So you're talking about mass production. Okay. Then that's it. Is that all? Go to the market. Let's say market. Unless you have the market, you are not going to mass produce. Okay. Let's say it's not comprehensive, but this is a fairly good list of things that you can think of for a product design stuff, right? Now tell me where DFMA, at what level it comes.
From the CAD model to the prototype.
One thing. Even in this, we have not gone into the details here. We have not gotten into the details here. Usually, this part is also divided into concept design. Then you go into detailed design. Then only you go into experiments. Okay, so these are stuff that we teach in our FCD or any design course. So first you try to do with a back of the envelope calculation, then you do a analytical model calculation, then only you go into a simulation to try to understand. These are all different levels of stuff, right? It's okay. So that's what I said, this is not comprehensive. Now tell me where DFMA finds a role in this list. Where do you or where can you use DFMA?
It should be used before the after the CAD model for manufacturing the prototype.
So you can talk about this. Then
It can also be a part of the detailed design.
it can also be part of the detailed design. Okay. It can also be part of the concept design. I mean, that's what I've written here. then obviously it is part of the prototype because you want to do that. Okay, the question is, this lets you do it before you go to the prototype, but obviously after prototype you check. That always happens. Good. So let's see what I actually have. Where does DFMA fit in a design process? You will be surprised that you almost got everything on this block. Concept design, you can use a design for assembly. It does not stop here because it gives suggestion for simplification of the product structure right now with the concept that you have. But as you pointed out, this itself could be a cyclic process because this is not your final concept. Okay. Then what happens, depending on the assembly, see, this becomes very important that we comfortably ignore. Depending on the assembly, you will have to choose your material and processes. Okay, this is something that we don't teach upfront in the design part. Okay, design for assembly needs to come upfront. How are you going to assemble it? Based on that is what I am going to choose my material. Because not all types of materials can be assembled on all types of materials. It becomes very important. What is going to sit on top of what and what is going to sit under what. It becomes very important. Okay. Then of course I can do cost estimates and all that. Then I look for a more economic material process. It's a combination of both material and assembly here, right here. Okay. And sometimes there also includes manufacturability. You cannot machine some hard metals. It is good from an assembly perspective, it is going to be good from a performance perspective. But from a manufacturing perspective, you don't want to use those. So then you will have to go back, change your concept accordingly and come. So much iterations at the concept level itself. We are not yet gone into the detail. Okay, then we will know what is going to happen with the performance. Then you choose the best design concept, as you guys pointed out. Then we look for manufacturing. Okay, here also we might use manufacturing. You use manufacture, then you do a detailed design for minimum manufacturing cost from there. Then you go to prototype and production. Okay, it's very similar to what we discussed. So what the point that I am trying to tell you is, there is no particular spot where you say I am going to use DFMA. People ask us, where do you use optimization? At any stage of design you use optimization. But you cannot take an optimization course and be ready to apply it in any stage of your design process. Because when we teach optimization, we say that you need to have a function that describes your objective. You need to have a function that describes your constraint. Oftentimes in real world you don't have that. You need to know how to approximate them. And when you are talking about a concept, you need to be able to choose multiple concepts. Concepts are A, B, C, D. So you need to have an algorithm that can evaluate A, B, C and D in a concept level. Okay, such techniques exist, but the only point is the notions are going to vary. At the concept design level, the notion of optimization is different. It only tells you, given these kind of an objectives, this is the best design. Then you have to go into the detailed design. Then you do a sizing or topology or a shape optimization, and then you look at a cost analysis, and then you choose the best design. Okay, so it's not like, okay, you have to come up with a final design and you can only change the width or the thickness and hence save money. No, you can upfront, you can say what is your important objective. If it is sustainability, you say I am interested in a sustainable design. Then yes, it's going to cost you more, but that's fine. That's my objective. I want to maximize sustainability. Okay? It will let you do that. It will let you choose materials accordingly, then accordingly manufacturing process, then accordingly your design process. Okay. Hence, DFMA is not just for one phase of product design. It is applicable and applied across different phases, whether it is concept design or it is detailed design or it is in prototyping. In the entire design process, it plays different types of roles, trying to give you the same kind of information on the ease of assembleness or evaluate a particular design from an assembly perspective and the manufacturing perspective. This is the idea of this take home information from this slide. Why should someone require a DFA tool? Something, the base things we have already discussed. It should be considered at all stages of design, and someone need not be an expert in all stages. So that is a problem. And today there is a big field called knowledge management. Now people are trying to use artificial intelligence, any kind. You go to a doctor, okay? So you go to at least in India, you go to a government hospital doctor. Any guess on how many patients they see on an average per day? 3 to 400 patients. That's right. If you compare it to the West, we are at least off by a factor of 15 to 20. If they see 30 people per day, I think he or she is an overloaded doctor. They don't meet so many people. Okay. So 300 to 400 patients they meet per day. Okay. So look at the amount of information that is stored. Huge. Of course, there is a larger probability of error also is there, but the amount of diversity of the information and the cases that they see is huge. Today you need to be able to manage those knowledge. That's one case, right? If you go to any company, let it be manufacturing and design company, there are few people called subject matter experts. They are the experts, legacy experts. They have been in the company for 30 years. You take a particular component and you ask them why this fillet was introduced, they know. You take a particular component and you ask in the supply chain, to whom should I go to get the knurling done? They will tell you go to geography 1 to get the knurling done in the same component. Knurling has to be done there. The filleting has to be done here. You need to come and cut the chamfer here. Then finally you need to go to this person to get the blank done. This is a supply chain information that a particular person gives. Now the company obviously does not want the information stored with an expert, but this is knowledge, okay, which is the company owns this knowledge and it needs to manage this knowledge. Tomorrow this particular expert retires, I need to have my next person being able to deploy this easily, straightforward, right? So for instance, you guys try to do some project for your dual degree project, right? Let's say that it's just one module of a larger project. So our knowledge management way is to ask you to give the codes, ask you to write a report. Okay, if you work part of one of such large projects, you will know. We would have asked you to create an index table. We'll say what is what code. You just click on it, it will take you to that code, and then a table. This table is given here. This is what you do, that is what you do, and all that stuff. So that is knowledge management. Okay. So basically today knowledge management is happening, and in that stage, people want to bring DFMA also in that, best practices in a knowledge management framework. Effectively analyze the ease of assembly. Okay. When I say effectively, it is not dependent on a person. It's not going to be dependent. I cannot bring an expert. Any person today, if there is a complex structure, you want to analyze it, you just plug it into a software. As long as you know how to run the software, you will be able to analyze it. It's as simple as it is. In such sense, you should be able to analyze the ease of assembly. Eliminate subjective judgment. This is what an expert brings. Still subjective. Subjective to my knowledge. That's all. I want to quantify it. So it is not qualitative, it is quantitative. You cannot say, that's what I told you, right? It is blue color, so I don't like that assembly, let's go with the red. That's not how you evaluate an assembly. We looked at simple metrics by which you can evaluate a assembly. So it should be a quantitative judgment, not a qualitative or subjective from a design assessment perspective. Easy comparison. It should not be obviously it should not be a complex comparison, easy comparison. Identify the problems up front. That is one part. Say that there is a problem. 2 is also try to provide solutions. I tell you that this is not going to withstand 10 cycles. That gives you only half the solution. I need to tell you what you need to do to such that it will sustain more than 10 cycles. That becomes important. Prevent fundamental failure. This is what the role of a engineer is, and these are the above bullets are just tools that let you do that. Okay. This is why DFA as a tool is required. Okay. Any questions?
There is this concept that we studied in FCD about identifying latent needs. Do you think that can be a part of how that can be used to something similar on that ground can be used for this DFA?
Sorry, latent needs.
Yeah, so we try and imagine the entire life cycle of the product. But do you think that can be?
Of course, it can be used.
Is it exactly the same thing, or do we?
No, it is not exactly the same thing. It's not exactly the same thing, obviously, because this is a field by itself. As we go deeper, you will know how people are nicely today. That's what I'm saying. You don't have to really take a screw and drive it and say that it will take you like 0.2 seconds. Okay, you can go to this and then it will tell you it will take, if it's an Allen screw, it will take you this much. If it is a different type of a screw, it will take you this much time. People have analyzed to that extent. Okay, anyway, coming back, so there are two components and you want a product. I get a product by assembling two components. What are the activities that are involved in this? Two components. Rather, two components, but I have to keep it here then only. I handle them, then I insert. So two major activities are there. What is it? Components. I handle them and then I insert them. So the process of assembly can be decomposed into, in a very generic sense. I should be able to handle and then I should be able to assemble. So part handling and part insertion. That is what assembly is. You can always say, sir, in this particular thing you had a hole, so you were able to do this. What if you had something like this, but you want to hold this together? Yes, you hold this and then you put a screw on top of it. Still, it's the same thing. Handling, inserting and fastening. Okay. You can subdivide it if you want, but this is the wide, very generic stuff. Handling and insertion. Okay. Now, to give you an idea on why this might become important from an handling perspective, right? This is easy for me to handle because this was a pen. Now imagine I wanted to do something larger. Okay, I might not be able to handle it in one hand. I might need both my hands to do that. Or it might not be of a geometry that it is easy for me to handle. For whatever reason, imagine that you had a rod with multiple, what do you call that? Which is sharp serrated edges, like your cycle chain. What do you call that thing? The cycle chain runs over something, so there is a bicycle chain that sprocket. There was sprocket with serrated pointed edges. For whatever reason, I have a shaft on which there are a lot of sprockets. I don't think I'm going to be able to just carry it in one hand just like that. I will have to hold it in both hands and then bring it to a place. Then I need to be able to keep it on something. Then I need to be able to do it. So that takes significant effort and time and all that, right? This is not only, it does not mean that it is only for bigger. Even for smaller things, very small things, you might want to use both hands. For instance, you might want to use forceps, right? If you go to a jewelry shop, okay, they usually use, the diamond is only very small, so they don't handle it with your fingers. They use a forceps. That is for some other reason also, but usually since it's small, they use a forceps to use it. Okay. You go to a hospital, if they are going to suture, okay, you see they don't handle the suture by hand. They always use only the tip of your scissors and the forceps, always. That is the best practice for a doctor, correct? In a similar fashion, I want to talk about handling and assembly.